Hello guys, so today we are here to solve this problem called time needed to buy tickets. This is our, you know, for 9th of April, this is the lead code challenge for the day, and we are here to solve this problem. So in this problem, we are given an int array called tickets and another int called k. So this is the int array tickets is about the n people in a line queuing to buy tickets. Okay, and 0th person is at the front of the queue and n minus 1th person is at the back of the line. So 0th person is at the front of the queue and n minus 1th person is at the back of the line. Perfect. You are given a zero indexed integer array tickets of length n. Okay, where the number of tickets that the ith person would like to buy is tickets of I. So in this tickets array, the ith person, the ith index is the ith person, you know, going to buy the ticket I. Each person takes exactly 1 second to buy a ticket, and person can only buy one ticket at a time and has to go back to the end of the line in order to buy more tickets. Okay, so it is return the time taken for the person at position K. So this here it is K is equal to 2. So K is equal to 2, 0, 1, 2. So this is 2 to finish buying tickets. So this person at the position K is equal to 2 has to buy 2 tickets. So see, at the K is the index location, and at that index location, the person has to buy 2 tickets. So this is just a coincidence that the person at the second index has to buy 2 tickets. So how much time it will take to finish buying all the tickets? So see, this person will buy 2 tickets. This person will buy, again, this will also, if this one also buys, 2 tickets, then this will also buy. So in the second round, after buying, everybody buys 6 tickets. So we have to return 6. So this is easy. And if you see this, in this, how much time it will take for the 0th person to finish buying all tickets. So he has to buy 5 tickets. So in the first round, it will buy, 1 ticket. So it will take 4. And then since all these values will be 0, it will keep on, buying this. So first it will buy 5, and then since others cannot buy 5 tickets, they can only buy 1 ticket. So they'll buy 1 ticket. So 5 plus 3 is equal to 8. So you know how we can solve this problem. So what we will do that we will call, we'll have one int sum is equal to 0. Okay. And then for int I is equal to 0, I less than tickets dot length plus plus I. And then what we will do that we will do tickets of I minus is equal to tickets of I minus is equal to 1. And then uh, just we can do like this, minus minus tickets, minus tickets, and then plus plus sum. And after doing this, so we will check if we'll check if this is 0. If tickets is 0, yeah, tickets of I is equal to 0, we will return this sum. And here also you can just return the sum. So this is getting a little redundant. But see, this loop has to go till the ticket tickets of k is greater than 0. So here we have to put the condition tickets of k is equal to 0. So this is a small k, not capital K. Tickets of k is not equal to 0. So we'll create one loop and we'll put this thing in the loop. Okay. Okay. So let's see how does it performs. Tickets dot length plus height. Expressing or less. There is mistake. Here there is a mistake. Let's match tickets plus sum. It is returning 17. How come it is returning 17? So you have to do this thing. If tickets of I is greater than 0, you have to do minus minus tickets. We'll take this under parenthesis, and then this one also will be under brackets. Okay, like this we will do. So let's run this once more. Perfect. So what we are doing that, we are taking, this thing under this outer loop in which the condition is that unless the kth index is not equal to 0, we'll keep on, iterating this inner loop. And in this inner loop, what is the condition? If the ith index of tickets is greater than 0, we decrement tickets by 1 and then increment the sum. And as soon as we find that, kth index, the index which was given to us, it is equal to 0, we return the sum. At the end also, that's what we have to do. Even if I return here -1, this is going to return the same correct answer, because at this point only we are returning it. And this is what we have to do. So I'll just, if I run like this, then also it will give the correct answer only. If I submit it, also it will give the correct answer. Perfect. So it doesn't matter, but I'm, just for the sake of consistency, I'm returning sum over here. If I return sum over here also, then also it will give the same correct answer. So I hope you understand this thing that, we are decrementing each value by 1 as long as ith value of the ticket is greater than 0. If it is 0, then we don't have to decrement it, correct? We don't want, the tickets ith index of the ticket to go below 0. So this is the logic of this. But if you see this, you'll feel that this is an overkill. Okay. So how can we, make this simple? Can we do this in one pass? I think we can do this in one pass. See, if you see this example, for this to become 0, okay, it has to buy 2 tickets flat. If we buy 2 tickets at this index, then we'll be getting 1. If we buy 2 tickets at this index, it will become 0. But it will not, it should not, nothing should become, less than 0. They all should become, at most they should be, at least it should become 0. It should not go down below 0. So here, if this is 2, if you decrement 2 from here, if you decrement 2 from here, so, because, yeah, and if you decrement 2 from here, then, we'll get 2, 2, 2. So all 3 2s will become 6, and that's the output. Consider this case. We decrement 5 from here. If we just direct decrement 5 from here, because our intention is to make 5 to 0. So we decrement 5 from here. We cannot decrement 5 from this because this value is only 1. So what is this value? We decrement whatever is this value, we decrement that by itself. So sum is 5 plus 1. then this also is 5 plus 1, and this also is 5 plus 1. So 5 plus 3 is equal to 8, and that's what the value is. So we have to write our logic in this way. And also, if we take this test case, if we take this test case and, write one more test case where this be, let we take this index as 9. Let's say this is as 9. So we will take 5 from the first. We want this kth 0 to be become 0. So we will take 5 out of this, then 1 out of this, then 1 out of this. And here, can we take 5? No, we will not take 5 out of this. Why we will not take 5 out of this? Because once we take 5 out of this, then this is 0. Okay. So once the iteration in which we take 5 out of this, it will be after, that iteration will be coming after when we have taken 4 out of this value. See, this is the logic that is here, and we want to expedite this logic. So in this logic, once we, at the fifth iteration, when we are taking 5 out of this, before that fifth iteration, at the fourth iteration, from 9, we'll be taking 4. And here we will be taking 1 because these values are very small. So, directly we can take whatever is, that. So 5 plus 1 is 6, 6 plus 1, 7, 7 plus 4 is 11. So the answer for this will be 11. So if I just run this, you can see the answer for the third test case which we built is 11. Now, again, we'll take this test case and we will put, 9 over here. So last 9 will be taking 4, but the 9 which is coming before 5, for that we'll be taking 5. So 5 plus 5 is 10, 10, 11, 12, and 4, 16. So answer will be 16. So let me just run and verify that. Perfect. So see, the answer for this will be, 5 plus 5, 10, 10, 12, 12 plus 4 is 16. 16 is not the, oh, 0 is, we don't want 0. We want, 1. Sorry. So if you take 1 for this case, then it will be 16. Correct. See, it is 16 because we want 5 to become 0. Okay. So now we have to formulate this logic. And how are we going to formulate this logic? So we will just, reset the code. If we reset the code, then what will be happening here? And sum is equal to 0 if for and I is equal to 0, I less than ticket dot length plus I. Then if tickets of I is greater than, we will take this, value sub is equal to tickets of k is greater than sub and I is less than equal to k, kth index. So in that case, what we will do, that we will do tickets of I minus is equal to sub and sum plus is equal to sub. Okay. Else if tickets of I is greater than sub and I is greater than the kth index, then in that case, what we will do, tickets of I minus is equal to sub minus 1 sum plus is equal to sub minus 1. Else, in the last case, what we will do that, we will do sum plus is equal to tickets of I, and then tickets of I is equal to 0. Okay. And then at the end, what we will do that will return the sum. If you run this, let me just run this. I is less than tickets, spelling is mistake. Tickets. Kets. Like this we have to do. Else if Tickets. Yeah, those spellings are correct. Perfect. So if you see this, this condition and this condition is same. So why not, we take it out and put that into a, single condition. So we will, we'll put this like this, and then we will do like this, if we'll do, and then we will do like this, and we will remove this part, and we will leave this part, and then we will remove this part, and then we will remove like this, and we will if we put it over here, okay. So like this we can do, yeah, and this part we can leave like this. So just let's run this. I'm sure that this is also going to give us the correct answer. If I is less than k, else I is greater than k. Not else, else. We don't need it like this. Else is enough for here. Perfect. Now we'll just submit it. What is the problem here? Tickets of I is greater than equal to sum. Huh? Yes. So we'll use this as a test case. Perfect. Now we'll submit it and it will be sub. Perfect. This is the solution that we wanted. And this solution is an efficient solution because everything is being achieved in the single pass. And what is being achieved over here, if we just go through the problem, what you will understand that we are suitably, decrementing that ith value of the tickets by sub, so that we are getting the, sum incremented appropriately, and that appropriate increment will be returning the correct value of sum. And that's how this sum is, we are achieving this sum in one pass. So as long as tickets of I is greater than tickets of k, we are, decrementing the tickets of I by tickets of k and incrementing the sum by tickets of k. If the index of I is, greater than kth index, so if index I is coming after k, then we are not decrementing it full, we are decrementing the tickets of k minus 1, and we are incrementing sum by tickets of k minus 1. So this part is clear, because why are we doing this? We are doing this because, once we come to the, kth iteration, in the previous iteration for all the indexes after k to the end of the tickets array, we are only subtracting it by tickets of k minus 1 times. because as soon as tickets of k becomes 0, after that we need not go beyond that kth index. So whatever subtraction is happening in between indexes after k to the tickets dot length index, that is happening in all the previous iterations of decrement, and that will only decrement till tickets of k minus 1. And that's why we are doing this sub minus 1, sub minus 1, like that decrement. And if this tickets of I is less than, sub, then in that case, we are directly, incrementing the sum by the tickets of I and making tickets of I is equal to 0. So I hope this logic is clear to one and all. If there is any doubt, please post it in the comments and I'll definitely supply clarifying statements to that doubt. So with this, we have come to an end of this video. Thanks a lot.